Welcome back, folks, to Scripting for Linguists. In this episode, I have this question for us. How can we identify prototypical concordances using sentence embeddings? Just to review, concordances are keyword and context lines. That is, you search for a term or a word in a big corpus, and you end up with that node word, what's called node word, and you have it in context. You have left and right context around the node word. It's one of the most basic techniques in corpus linguistics. And I'd like to know how we can find the prototypical concordances or sentences using sentence embeddings. In a previous video on this channel, I looked at how to organize concordance lines by semantic meaning in a multidimensional vector space using sentence embeddings. And I use this model here. This is the all mini LM L6 V2 from Sentence Transformers on Hugging Face. And this is a sentence transformers model. It maps sentences and paragraphs to a 384-dimensional dense vector space and can be used for tasks like clustering or semantic search. So in my previous video, I used this to simply organize all the concordances using this sentence transformers model. And so what I've done is I've taken my script from before, that previous video, and I have it here, but I've extended it to answer this current question. Again, how can we identify the prototypical concordances or sentences in the groups of semantically cohesive concordance lines? So just to refresh your memory a bit from that previous video, if you have not seen it, I will link to it above, below, in the description, what have you. I use two corpora. One is Saints, a history of the Church of Jesus Christ of Latter-day Saints, 4-volume history, as well as Brown corpus from Brown University from 1961, the OG of corpora in the corpus linguistics world, modern corpus linguistics. And so I don't want to go through the whole video. I encourage you to look at that previous video. The idea I just want to review is that we end up with concordance lines like we see here. Let me remove myself real quick if I come back over here and remove myself for a second. We have concordance lines. We have the word bank. I search for bank or banks, and you can see that we have some that are a riverbank and others are financial institutions. Okay? So the purpose of the previous video was to say, okay, let's use sentence embeddings with that model I just mentioned, the all mini LM L6 V2, and create clusters. And number of clusters, we use the elbow method to identify how many clusters we should specify. With banks, we're going to say 2 because there's a bit of an elbow right there, right? Okay, and then here we do the actual k-means clustering using the embeddings that we got from that model, and we add those cluster labels to the concordance lines on the far right hand of the screen. Now we have a new column called cluster and just has an identifier, 0 or 1, because we have two clusters. Okay. So that's cool. We can look at each one in turn, individually if you like. For example, a cluster with an ID of 0 seems to be riverbanks by and large. The cluster with an ID of 1 seems to be financial institutions, banks by and large. But they're not perfect, right? There's a bit of error there. But by and large, these are financial institution banks. Okay. So this brings us to my question for this video is how can we take those sentence embeddings and find the prototypical concordances or sentences for each of those clusters. So we have, say, 2 clusters for bank, financial institutions, and riverbanks. How can we find the n number of prototypical sentences? Just a little review on what prototype theory is about. We have categories, and we have some members that are very prototypical, like very central to the category. Some members that are a bit less central, but very, very much that category. We have other members that are farther out and some that are very peripheral, right? It's a gradient thing. The classic example when talking about prototype theory, the hello world, you might say, of prototype theory are birds. So we have sparrows and robins, which are very prototypical birds. They're small, they fly, they eat seeds and bugs, they build nests up in trees and lay their eggs up there. Right, those are very prototypical birds. We have some birds that are larger or smaller than those birds, say eagles and hawks and bigger birds. We also have smaller birds, like hummingbirds, that are less prototypical, but they're still very much a bird, right? And we have other birds that are even farther out from the center of that, say vultures. They don't eat seeds and bugs. Maybe they do. They probably do. They eat whatever. But they also eat dead carcasses, right? They eat carcasses that have died on the Serengeti or on the side of the road. Then we have birds that are way far out, like penguins that don't fly. They swim. And ostriches and emus that don't fly. They run really fast. So those are less prototypical, but they're still birds, right? So anyway, that's the idea of prototype theory. So now I'm curious to know, okay, so I have concordance lines that have been assigned to, in this case, one of two categories using k-means clustering, which is an unsupervised machine learning algorithm, using the embedding vectors that we got back from the sentence transformer model. I'd like to know which of the sentences in each cluster is the most prototypical. And we can actually use cosine distance to do that. So we have a multidimensional space into which the sentences are placed, right? And it's a 384-dimensional space like we saw on the doc page at Hugging Face. And so we can find the centroid for each category. We can take all the sentences that were assigned to category 0 and find its centroid, its center point. And we can take all the sentences that were assigned to category 1 and find its centroid. And then in each of those categories, take all the sentences or the embeddings and find their distance to that center point. And then have it display the n number of most prototypical sentences for each of those categories. So that's what we're doing here. So I have a little helper function I defined called get distance from cluster centroid. You pass in 3 arguments that we have above from our previous video. And we're going to calculate the cosine distance of each concordance to its corresponding cluster centroid as assigned by the k-means algorithm, right? And it returns a list of cosine distances. Good. And then I have another helper function I defined, which is take in the pandas data frame, which is holding the concordances or the keyword and context display, and then give me the n number of most prototypical sentences or concordances in each of those clusters. That's just a simple little thing with pandas data frames. So let's go ahead and try that. I've already done so before the video started. So what we can do is, let's say we want to look at the 3 most prototypical concordances or sentences for each of those 2 categories into which bank or banks was assigned by the k-means cluster. So here is my souped up concordance display. Let me remove myself again for a moment. Gotta come back and click on OBS and then do this, okay? So what we have here is, on the far right, we have a new column called distance. And this is the cosine distance between this particular concordance line and the centroid of the cluster with the ID of 0. And the smaller that number, the closer it is to that centroid point. So here we have, during the baptism, some men stood along the bank of the short distance back and heckled the believers. Okay? When Joseph and his companions rode their horses along the banks of the river for 10 miles until they arrived at that place. Okay, they scrambled to find better shelter. The banks of the fishing river disappeared as the water rose. So these are clearly banks of a river, and these are apparently the most prototypical 3 sentences in that cluster 0. Because they are closest to the centroid point of that cluster based on cosine distance on the far right of my screen. The bottom 3 concordance lines here, we have cluster 1. You can see in the second from right column, cluster 1 there. And let's see what we have here. Economy and raise money for the church. Like other small banks in the United States, it would provide loans to borrowers. New loans to relieve the church's financial burdens in Utah. Banks were falling and agricultural prices plummeting. Okay, clearly financial institutions to another city to try to partner with an established bank there, but the Safety Society's poor start had shaken the. So these are the 3 most prototypical sentences in the cluster that was assigned a category or a label of 1, which clearly deal with financial institutions. Okay, so that's cool. Let's try it now with Brown, using the same example that I used in my previous video, which is run or runs. So let's reload our corpus here. Let's come back up here and get brown corpus, the OG of the corpus linguistics world, the first kind of big corpus released in 1961, if I'm not mistaken, at Brown University. Okay, so we have 500 files. Good. Let's search for run or runs. Create a concordance lines with that. We have 302 concordance lines. Great. We can take a look at those if we like real quick. Here they are. Run for re-election, run a billion, run ahead of his GOP opponents, hit and run. Okay. So there they are, just kind of interspersed. Then we're going to go through and do the sentence embeddings. Again, I'm clicking through this quickly because I have a previous video in which I take time to explain this in a bit more detail. I just want to get down to the point of this video, which is finding the prototypical sentences. Here we have k-means clustering. I think it tells us to specify about 3. Yeah, let's say there's an L right there at that point, which is at 3. So let's say give me 3 clusters, k-means please, with those numbers that came out of the sentence embeddings. Put them onto the data frame that is our concordance display. And sure enough, there they are on the right side of my screen. I'll remove myself again for a second. Over here. Okay. There they are on the far right of the screen, 0, 2, 2, 0, 1. These are just simply IDs for the identifiers for the clusters. Okay, cool. That's awesome. And we can look at those individually if you like. But let's jump down to the point of this video, which is down in here. We don't need to redefine those helper functions. We'll just skip right down to here. And then let's take a look at the top 3 sentences for those 3 clusters. So just to be clear, we have 3 concordance lines for each of these clusters. The top 3 concordance lines are belong to cluster 0, and the next 3 belong to cluster with an ID of 1, and the bottom 3 belong to the cluster with an ID of 2. Let's take a look here. Of us felt that it might catch on for a run in Chicago, continue as a road company, and eventually become, okay. Some would say that they were not permitted to run their business only for profit, even putting it that federal spending and the reduction in business inventories have probably run a good part of its course, the increase in retail. Okay, so these are runs, like run a business there, run in Chicago. I'm not sure exactly, some type of run in Chicago. So it looks like cluster 0, that is cluster that has an ID of 0, is like run a business or run, here's another business inventories that probably run a good portion of its course, okay. Some type of like run a business or run an organization or maybe a campaign, I'm not even sure. Okay, next 3 down that have a cluster ID of 1 are these. Let's see, team thought no one was out there, hits 7 home runs in 4 months, 3 more than his total. So that is a baseball runs. Batting for first place appropriately, the emphasis on the home run at a peak this year came into being a baseball. So that's another baseball run. The man twice last season on dramatic home runs. Friend is off to a good start with their record. That clearly is home runs in baseball. So those are the most prototypical sentences in the cluster that has ID of 1. Those are clearly baseball. And then let's look at the next one, the bottom 3 prototypical sentences for the concordances or sentences that were assigned to the cluster with an ID of 2. A group of men and dogs circled him. He wanted to run, but he knew that if he did, he would be something. Okay, that looks like physical running with your legs, moving very quickly, right? Him, however, that she was tired and winded from the run up the reef and would not charge, yet he moved. So that again is running physically, run up the reef. She was tired and winded from the running up the reef. His belly and thought he had found the strength to run with us, but he collapsed and lay on the ground. So again, these bottom 3 are the most prototypical sentences in the cluster that was assigned an ID of 2. And these clearly deal with running physically, like physically moving your legs quickly. So there you have it. We have 3 pretty cohesive senses or meanings of run or runs. We have run a business or some type of organization. We have run or runs in baseball, and we have run like physically run. And these are the most prototypical sentences or concordances in those three clusters in the Brown corpus. So there you go. To answer our question back here, how can we identify prototypical concordances using sentence embeddings? We can find the centroid of each cluster after using k-means clustering to figure out how far each sentence or concordance is from that centroid, and then just get the n number of concordances that are closest to that centroid. In this case, I just used 3. As a quick example, you could use 5 or 10 or 50 or whatever number of concordances that you'd like to look at. But it's kind of a cool way to use sentence embedding with k-means clustering, finding the centroid, and then finding the most prototypical sentences in each of those clusters. I need to cite my source here. I got this idea from a pre-conference workshop held at Corpus Linguistics 2025 in Birmingham, England. I went to a pre-conference workshop run by Nathan and Tim, shout out to them, in which we looked at word embeddings. And I thought, well, if we can do it with word embeddings, why can't we do this with sentence embeddings? And sure enough, we can. We can do the same idea of finding the centroid of a cluster based on k-means clustering, and then find the words, in our case, sentences, that are closest to that centroid point. So there you go. I hope that was useful. Again, I'll leave a link to my Google Colab notebook in the description of this video. If you enjoyed it, give me a thumbs up. Share it, leave a comment, all that good stuff. Subscribe if you haven't subscribed yet. See you next time. Thanks. Bye.